Today's lesson is on chapter 7, part 1. Now, for triangles, you would have already watched the first video where the teacher introduced you on the different types of triangles, as well as the different types of angles within the triangle. So we'll move on now to the next section. Now, we have learned in primary school that the sum of the angles in a triangle is 180 degrees. Whenever we want to use this property, say for example, we want to find the value of angle A, when we are given B, for example, equals to 30 degrees and C equals to, for example, 50 degrees. If we want to find the value of angle A, this is what we'll do. Angle A is 180 degrees minus angle B minus angle C. Substituting the values, minus 30 degrees and minus 50 degrees, we get the answer of 100 degrees. Now this is very straightforward, but I would like to let you know that this is incomplete. Why? Because over here in your very first line, you used a certain property. The property is that the sum of the three angles in a triangle is 180 degrees. So when you use a property, you must write down the name of the property. Now in this case, we will need to write down the abbreviation, angle sum of triangle. What this means is that we are saying this property is known as the sum of the angles in a triangle is 180 degrees. Okay, so this is a short form that we can use. The next property over here, the base angles of isosceles triangles are equal. So whenever you are solving a problem that involves you using the property of base angles of isosceles triangles being equal, we will need to write down this particular abbreviation, base angles of isosceles triangles. The final one, if you are using angles in an equilateral triangle being 60, you write down angles of equilateral triangle. We'll see how we can use this in the subsequent problems. Now moving on to point 4, sometimes we will need to use this very interesting property known as the triangle inequality. What does this mean? Now the explanation is as such. In any triangle, doesn't matter which kind of triangle it is, the sum of any two sides, when you add any two sides randomly, it must be greater than the third side. Okay, so for example, if I have a triangle that looks like this, A, B, and C, if I randomly choose two of the sides, for example, A plus B, the sum of these two sides must be greater than C, definitely. What other options are there? We've got A plus C, it must be bigger than the other side. We've also got B plus C must be greater than A. Why is there such a property? You can go and draw triangles and experiment and discover for yourself why this property must be true. Okay? In other words, you can test yourself. Am I able to construct a triangle where A plus B is less than or equal to C? Okay, A and B are just two sides where C is the final side. Go and try this out. The next property over here is that in any triangle, the longest side is opposite the biggest angle. This must definitely make sense. So for example, if I've got a triangle that looks like this, let's give it a name. Let's give it some name, A, B, and C. Okay. So I've got this triangle known as ABC. The side AC must be opposite this angle X over here. Because AC is the longest side, and visually we can see that X is also the largest angle. So this property is known as largest side opposite biggest angle. Whenever we want to call out this property, this is what we will write. So then the opposite must be true. If we look at this triangle, the same triangle, where is the smallest length? The smallest length must be AB. That's the smallest length, and visually we can see that this angle over here, angle Y, is the smallest angle. So the shortest side is opposite the smallest angle. And then the abbreviation, shortest side is opposite smallest angle. So let's do a quick example over here. We've got ABC with 3 lengths given to us. Well, we can see that just randomly choose any of these two numbers. 10 plus 13 is more than 9. 10 plus 9 is more than 13. 13 plus 9 is more than 10. This satisfies the triangle inequality in part form, but that's not the point of this question. Okay, they are asking for the largest angle and the smallest angle. So it will be useful for us to do a quick sketch. Now I know that BC is the largest, is the greatest length. Let's put it at the bottom, BC 13 cm. AB is 10, okay, AB 10 cm, and finally AC being the shortest, 9 cm. Okay, now based on this, I can tell that the largest angle must be angle BAC, because it is opposite the largest length. Therefore, the smallest angle must be opposite the smallest length, which is ABC. So this is the property of a triangle. When we want to use this, we have to write both of these two abbreviations, depending on which you're referring to. Now we are going to go in the other direction. This time we are given the angles, and we have to find out which is the longest side and which is the shortest side. So again, we will want to do a quick sketch. Now triangle PQR 70 degrees. Okay, let's randomly P, Q, and R. This is approximately 70 degrees. QRP, Q, then R must be somewhere here. P is up there. Okay, it is quite a big angle of 85. So this is my angle R. So leaving with QPR 25 degrees, small angle. The longest side must be opposite the largest angle. So this is the largest angle, this must be the longest side, that will be QP. And the smallest side must be opposite the smallest angle, that is QR. The next property that we are using is that the exterior angle of a triangle. What do we mean by exterior angle of a triangle? Over here, X. This is known as the exterior angle of a triangle. It is equal to the sum of the two interior angles. Okay, so interior angles are straightforward. For example, no, not for example, in any triangle we've got 3 interior angles. Okay, A, B, and the next one, C over here. There are 3 interior angles. If we are talking about angles A and B, if we choose these 2 interior angles, then the sum, when I add A plus B, it will be equal to this particular angle X. And this angle X is known as the exterior angle. How did this angle come about? Well, we've initially got this triangle. I'll highlight it. This is the original triangle. To get the angle X, what we did was to extend this line. We extend it. Now, the angle formed by the triangle, the yellow triangle, and the green line, this angle is known as the exterior angle X. And there is a property that X is equal to A plus B. Why is that so? Let's discover this for ourselves. Let's say this is angle C. Angle C is equal to 180 degrees minus angle A minus angle B. Reason, angle sum of triangle. Now this will be whatever angles that are A and B, you will just substitute them in, okay? So this is my angle C. If I want to find the angle X, it must be 180 degrees minus angle C. Reason, adjacent angles on a straight line. Okay, now we have the opportunity to substitute angle C. So early on we said that, hey, C can be replaced by 180 minus A minus B. Let us do that. Minus 180 degrees minus angle A minus angle B. Okay, 180 degrees. Now we are going to remove the brackets. Since there is a negative sign in front, I'm going to switch all the signs. So positive 180 degrees becomes negative 180 degrees. Negative angle A times a negative becomes a positive angle A. Negative angle B, when you remove the bracket with a negative sign outside, becomes positive angle B. Continue simplifying. 180 minus 180, that's nothing. We're left with angle A plus angle B. And here we have the conclusion. Angle X is equal to angle A plus B, as shown over here. When we want to use this property, we write down exterior angle of triangle. So here we have, like what I mentioned earlier on, when the side of a triangle is produced. So this is our triangle. When a side, follow the green highlighter, when a side is produced, that means we extend it, we will form an angle outside the triangle. Here, this is the angle that is formed. It is known as an exterior angle. Okay, so this particular exterior angle must be the sum of these two other red angles. Okay, let's try exercise 1 now. We've got AB is equal to AC. AB equal to AC. Okay, quickly we know that this is an isosceles triangle. And we also know that DA is parallel to BC. So we know that we are going to be using either our corresponding angles, our interior angles, maybe our alternate angles. Okay, so now find the angles X, Y, and Z. Sure. First, we see that EAD is 55 degrees. Oh, I think I see a letter Z. A letter F. Let me highlight it for you. Over here. Can you see the letter F? But it is upside down. This letter F over here reminds us of corresponding angles. So where are the corresponding angles? We'll need to state them down very clearly. Angle Z is equal to angle EAD. Okay, so here we write down corresponding angles, parallel lines. And here we have 55 degrees. Done. Next, we've got, since we already have angle Z, since this is an isosceles triangle, then the two base angles must be the same. We know that angle Y is not equal to angle Z. Write down the reason. Base angles of isosceles triangles. And this is also 55 degrees. Do not just straight away write down Y is 45 degrees without any reason. We need to state reason. So now that we have got Z and Y, we are ready to find X. Angle X must be 180 degrees minus our angle Z minus angle Y. Reason, angle sum of triangle. So this is 180 degrees minus 55 minus another 55 degrees, and we have a value of 70 degrees. So every time I call out a property, I must state the reason. Let's continue with exercise number 2. AB is equal to AC. Okay, I see an isosceles triangle again. ACD is 9x. This is the exterior angle, which means that 9x must be angle Y plus whatever angle this is. Okay, next, BCA is 3x. Okay, looks like these two will add up to be 180 degrees since they are adjacent angles on a straight line. And here we've got y degrees, meaning if I take 180 minus y, I divide by 2, I should get 3x because this is angle sum of triangle. So now we are ready to calculate the value of x, part A. We're going to make use of this property. 9x plus 3x degrees must be 180 degrees. Notice that I wrote the degree symbol. I am very careful whenever I deal with angles. If the question has a degree for x, I will include it. Whereas in the previous case, notice that x, y, and z, they do not have degrees, so my x, y, and z do not have degrees, but the final value will have an angle of a degree symbol. So here I have written down the equation, but it is incomplete. I have to write the property, otherwise you get no marks. So adjacent angles on a straight line. So make use of the time now to go and memorize. So 12x is 180 degrees, therefore x degrees must be equal to 15 degrees. So if they want the value of x has a value, it is 15. Part B, we want to find angle y. There are at least two methods I can think of. First is we make use of the exterior angle. Since this is also 3x, and I already have the value of x, I will just take 9x minus 3x, I will get y. Alternatively, I also can use angle sum of triangle. Since I know 3x, I know 3x, I already minus the both of them. Okay, and that is actually what I'll do. So y degrees must be equal to minus the other two 3x's, which is angle ACB minus angle ABC. So it is known as angle sum of triangle. Okay, now did I state in my equation that angle ABC is also 3x? I know I've indicated in the diagram, but I haven't written it out. And we know that it is 3x because it is the base angle of isosceles triangle. So later on, we will have to include that. So this is 180 degrees minus ACB. We can do the substitution already. 3x, so 15 degrees. Now minus another ABC. ABC, we are going to write this down as 3x. And we're going to state the reason. Base angle of isosceles triangle. Okay, we're not going to immediately substitute yet. We are going to show that I know this is 3x because it is base angle of isosceles triangle. Now next part, 180 minus 3 times of 15 is 45 degrees. Minus again another 3 times of 15 degrees. We get the value of y as 90 degrees. So since they want the value, y is equal to 90. In exercise 3, find the value of the unknowns in the following. Since these are parallel lines, we go back to our F, U, and Z. Which letters can we find over here? There are quite a number, but from what I see, the most straightforward one that we can use will be this, our interior angles. So the property tells us that when we add 3x plus 55 plus 2x, it must be 180 degrees. State the reason: interior angles, parallel lines. Okay, so just solve. 5x will give us 180 minus 55, which is 125. So x must be, notice that I just dropped the degrees, so x must be 25. So in this way, I don't have to write x degrees is 25 degrees, therefore x equals to 25. Now for the remaining time, please do part B, exercise number 4, and you may start on your homework questions. Okay, this set of notes as well as this set of homework, they are both due today, 10 p.m. and today is the Wednesday. Okay, as I was saying, this will be due on 29 April, 10 p.m. Okay, both the set of notes as well as the textbook questions. You have about one period left, 35 minutes. You will be able to finish part B as well as exercise 4, and you will be able to start on your homework from your textbook exercise 7.1. When you are done, please take a picture of your notes, okay, from page 2 all the way down to page 4, everything completed. Save it as one PDF file, upload it by 10 p.m. today. Then take another picture of your of your homework from your textbook exercise 7.1, save it as one PDF file and upload it. Before you upload anything, please check your work according to my work solutions, which is uploaded as well. You have to make sure that the presentation is correct. It is easy to get the correct final answer, but if your intermediate steps do not have the properties, the reasons stated, you will be penalized. You will definitely not get the full marks. In fact, you may not get any marks at all. So please make it a habit now, start memorizing the properties.